Namaste students. Now today we are going to see applications of derivatives, maxima, minima. The previous class we have seen tangent and normal, increasing, decreasing. By using first derivative test, find maximum and minimum. Let f be a function defined on an open interval I. Let f be continuous at critical point C in I. Then first condition, if f dash of x changes sign from positive to negative as x increases through C, that is, if f dash of x is greater than 0 at every point sufficiently close to the left of C, and f dash of x is less than 0 at every point sufficient close to the right side of C, is a point of local maxima. So what is the condition for the first derivative test of local maximum? F dash of x changes from positive to negative. Second, if f dash of x changes sign from negative to positive as x increases through C, that is, f dash of x is less than 0 at every point sufficiently to left of C, and f dash of x is greater than 0 at every point sufficiently close to the right side of C, then C is a point of local minima. So what is the condition for first order derivative of local minima? F dash of x sign changes from negative to positive. Third one, if f dash of x does not change sign as x increases through C, then C is neither a point of local maxima nor a point of local minima. In fact, such a point is called a point of inflection. So what is the point of inflection? F dash of x does not changes from positive to negative. It is increases or decreases. So there is no change. It is called a point of inflection. Second derivative test, we have to find a local maximum and minimum. Let f be a function defined on an interval I and C belongs to I. Let f be twice differentiable at C. Then x is equal to C is a point of local maxima. If f dash of C equal to 0 and f double dash of C is less than 0, then the value of f of C is a local maximum value. What is the second derivative test condition? First find out f dash of C. F dash of C equal to 0, then f double dash of C is less than 0, then f of C is a local maximum value of f. Suppose when we substitute x equal to C is a point of local minima, f dash of C equal to 0 and f double dash of C is greater than 0. In this case, f of C is local minimum value of f. The test fails f dash of C equal to 0 and f double dash of C is equal to 0. F dash of C equal to 0, f double dash of C is less than 0, it is the local maximum. F double dash of C greater than 0, it is local minimum, and f double dash of C equal to 0, the test fails. Let f be differentiable function on a closed interval I, and let C be any interior point of I. Then we have to find out absolute maximum or absolute minimum. First condition, f dash of C equal to 0 if f attains its absolute maximum value at C. Second, f dash of C equal to 0 if f attains its absolute minimum value of C. In view of the above results, we have the following working rule for finding absolute maximum or absolute minimum values of a function in a given closed interval a comma b. Actually, the diagram shows that absolute maximum is nothing but maximum among all maximum is called absolute maximum. Minimum among all minimum is called absolute minimum. Now we are going to see the working rule of absolute maximum and absolute minimum. Step 1. Find all critical points of f in the interval, that is find points x whether f dash of x is equal to 0. Step 2. Take all the endpoints of the interval. Step 3. All these points listed step 1 and step 2, calculate the values of f. Identify the maximum and minimum values of f out of the values calculated in step 3. This maximum value will be the absolute maximum, that is greatest value of f, and the minimum value will be absolute minimum, that is the least value of f. So what is absolute maximum? Maximum among all maximum value is called absolute maximum. Minimum among all minimum value is called absolute minimum. Thank you.